Alright guys, we're looking at quadratic transformations today. So the first quadratic that we're looking at is the parent function, y, or f of x equals x squared. Okay, we call that the parent function because there is no transformations to that function. It is the original function. Alright, so we're starting off with a table of points. Okay, so what you're doing is you're taking your x value, plugging it in, and then finding your f of x or your y value so that we can plot the points, right? So if I plug in -3 squared, that gives me a positive 9. If I plug in a -2 squared, that gives me a positive 4. -1 squared is a positive 1. 0 squared is 0. 1 squared is still a positive 1. 2 squared is a positive 4, and 3 squared is a positive 9. So if I was to graph those points, here's 0, 0. Here's -1, 1. We also know that this is the axis of symmetry. So then I have another point that is equal distance from that axis of symmetry at 1, 1. We have a point at 2, 4. Again, equal distance on this side at -2, positive 4. We can connect those and make our parabola. So the domain is asking for all of the x values in this parabola, Okay, so this arrow means that it keeps going. So we would start at -infinity and we would end at positive infinity. We could also say all real numbers. The range, the lowest point on the graph, starts right here, and the y value at that point is 0. And it goes to positive infinity because those are arrows. Okay, I could also write it like this: y is greater than or equal to 0. You will see it like this a lot on your EOC. The vertex is right here at the origin, which is at 0, 0. It says, do you notice a pattern with the points? Yes. Okay, each y value is the square of the x values, right? Because all we're doing is taking x and we're squaring it. And also, all of my y values are positive. Because when you take a negative and you square it, it still becomes positive. It says this pattern repeats itself with every quadratic function, with variations depending on the equation, right? So we could have a negative outside of my quadratic equation, and yes, all of my y values may not be positive. So let's go to number 2. Like I'm saying, we could have a negative outside of my quadratic equation, or my quadratic function, and my y values might not all be positive. So again, this is y equals -x squared. So if I want to find some points, all I'm going to do is take my x value, plug it in, and then find what y is equal to. So y equals -x, which is -3, squared. So -3 squared is a positive 9. But now, once again, you still have that negative outside. So my answer is -9. Same thing with -2. Y equals -2 squared, because x is -2 squared. -2 squared is a positive 4. But then once again, we still have this negative outside, so it's a -4. This would be -1. 0 is still 0. 1 is a -1, and a -4, and a -9. So to plot those points, here's 0, 0. I have a point at -1, -1, and a point at positive 1, -1. I've got a point at -2, -4, and a point at positive 2, -4. Connect those, make my parabola. Once again, the domain is asking for all of the x values. That arrow tells me that it keeps going. So we could say -infinity to positive infinity, or we could say all real numbers. The range, this arrow says that it starts down here at the bottom. We could call that -infinity, right? So it starts at -infinity, but here's the highest point on the graph. So it doesn't go all the way to positive infinity. It stops right here at 0. And we could say y is less than or equal to 0, because all of my y values have to be less than that point. The vertex is still at the origin, 0, 0. We haven't moved it. So it says, how does f of x equals x squared change? So what changed? Right here, up here, we were going upward. Okay, here we were going downward. Now, the vertex didn't move. The vertex is still at 0, 0. So I didn't shift it. All I did was flip the graph over the x-axis. Right? It's the same as that graph. All I did was flip it over the x-axis. So how did f of x equals x squared change? The graph is reflected across the x-axis. So it says, what's the difference between f of x equals x squared and f of x equals negative x squared? Okay, well, if you look, negative 3, 9, this is negative 3, negative 9. Negative 2, 4, this is negative 2, negative 4. Negative 1, 1, this is negative 1, negative 1. So instead of that being a positive 9, it's now negative. So all the y values became negative. It was the same number, it was just a different sign. And so we could say it's the opposite y value. I'm sorry, you can't see that. So my rule is negative x squared, or f of x. So once again, the numbers were the same, I just changed the sign. Negative 3, negative 9, this is negative 3, positive 9. All I did was change the sign. Let's look at vertical translations. Okay, so now we are going to move the quadratic. So my first example is f of x, or y, equals x squared plus 5. Right, so again, once we're doing is we're going to plug this in for x. So this is y equals x squared, but again, x is going to be negative 3, so negative 3 squared plus 5. Negative 3 squared is a positive 9 plus 5, that's going to give me a positive 14. I'm going to do the same thing with negative 2. Y equals negative 2 squared plus 5. Negative 2 squared is 4, plus 5 is 9. Okay, I'm going to fill in the table. This is going to be 6. This is going to be 5. This is going to be 6, 9, and 14. So we can plot those points. Okay, I'm going to start right here at the vertex, which is at 0, 1, 2, 3, 4, 5. I've got a point at 1, 6, and negative 1, 6. Connect those, I can make my parabola, so it's way up here. So instead of your vertex being at the origin, your vertex is up here at 0, 5. Now, the domain has not changed. The domain is still all real numbers. The range, here's the lowest point on the graph, so y, because the range is y values, y has to be greater than or equal to the lowest point on the graph, right? So the lowest point on the graph is 5. So it says, how does this change from my parent function, x squared? Well, my parent function started here. This function starts here. So we shifted the graph up 5 units. And then all y values increased by 5. All of my y values increased by 5. So what's the rule? Well, we're just going to take f of x, whatever we got, and we're going to add 5 to it. So if this, we shifted the graph up 5 and it was a positive 5, guess what number 4 is going to do? It's a negative 5. You're probably right. Yeah, it's going to shift it down 5 units, absolutely. So once again, let's plug in our points. So I've got negative 3 squared minus 5. That gives me a positive 4. This gives me a negative 1, negative 4, 0, negative 5, 1, negative 4, 2, negative 1, and then 3, positive 4. So if I was to plot those points, I'm going to go down 5. 1, 2, 3, 4, 5. I've got a point at negative 1, negative 4, positive 1, negative 4. Connect those. Your parabola looks like that. Domain is still all real numbers. Your range, here's your lowest point on the graph. So y needs to be greater than or equal to that lowest point, which in this case is a negative 5. And your vertex is at 0, negative 5. So it says, how does the graph change? It's been shifted down 5 units. And then all y values decreased, because it's a negative, right? Minus 5, decreased by 5. Alright, so let's look at our functions and then how it affects the graph, right? So here's our parent function. So if it's a negative x squared, what happened? If I go back to number 2, we reflected across the x-axis. This is number 3. Okay, what happened on number 3? The graph shifted up 5 units because we have a plus 5 after that x squared. Okay, or we could say translated up 5. Same thing here. This is a negative, so instead of it being shifted up, it's shifted down. Or we could say translated down 5 units. So once again, here's your parent function, x squared. Okay, so what's the change from that to this negative x squared? Well, that negative out in front is going to reflect it across the x-axis. So instead of my y values being positive, they're now negative. This plus 5 at the end is going to shift it, translate it vertically 5 units up. Minus 5 would shift it or translate it vertically down 5 units. Awesome blossom.